Good afternoon. My name is Raffaele Siepe and present the work under numerical evaluation and experimental comparison of elastoplastic stress strain distribution around the corner size of Notched spaceman. Okay, the focus of the paper is the study of stress strain field at crack tip of Notched cracked spaceman. The activity has carried out through several steps. First, fatigue testing to generate a crack in the notched spaceman, then detecting of crack size and shape, and then firm analysis in linear elastic material condition to evaluate the convergence model, and then FEM analysis with nonlinear material condition to investigate the effect of yielding and crack tip. Finally, comparison of numerical and experimental data. Okay, the first step is the fatigue testing. The specimen has been carried out in constant amplitude load control with load ratio is 0.05 and maximum load is 16.5 kN. The specimen was made in aluminum alloy 2024-53 and the tested were stopped when the crack length in the notch root was about 2 millimeters. Two type cracked specimens were obtained, specimen with a long through crack and specimen with a short crack. Okay. After that, the specimen was subject to static load for measurement by strain fields around the crack tip. Two types of measurement was made. The specimen with a long crack was subject by static load by 9 kN, and then the strain field was measured by neutron diffraction technique. Then, while the specimen with the short crack has been subject to the load of 80 kN, and then the strain field has been measured by synchrotron radiation diffraction technique. After that, the crack shape and size was taken by a digital camera, and the depth of the crack was measured after the specimen has been frozen and then opened up. These are the profiles of the two types of cracks. These profiles were used to make a FEM model. Okay, the first case, the specimen with the long through crack. The crack plane is not in the middle of section of the specimen. The specimen was modeled with 20 node elements with 3 degrees of freedom for each node. The boundary condition, the specimen was constrained in all directions on one side, and on other side was applied a uniform pressure of 100 megapascal. Also, the zeta constrained along zeta direction, constrained for avoid the autumn plane. Okay, several models were created, 3 full-scale models with 8, 16, and 32 elements along the front of the crack. Also, to increase, in order to increase the number of elements on along the crack front, submodeling technique was used, and in these figures, show the mesh of the crack tip with 64 elements on the front. Okay, this linear analysis. Linear analysis has been carried out to obtain the convergence model. Okay, the H convergence parameters is stress intensity factor. So the model with 32 and 64 elements give the same results. So for nonlinear analysis, the model 3 with 32 elements was used. Okay. The FEM nonlinear material analysis was used nonlinear material. The model material is bilinear, and this is the difference of the stress distribution in the plane with zeta equal 2 millimeters between nonlinear and linear analysis. The distribution is the same. We have just difference of the peak of the stress for all direction. Now, for correlate numerical and experimental results, we have made a new analysis with a uniform pressure applied over 45 megapascal, and along the direction parallel to the crack propagation, two numerical value has been evaluated: local strain value and average strain value. Okay, local strain value is the nodal values of the nodes nearest to the measure point. Okay, while average strain values is the average of the nodal strain of the nodes contained in gauge volume. Okay, this is the results. Okay, we have some difference between local and average value close to the crack tip. This because close to the crack tip we have a high gradient of the strain. So the average the distribution in the gauge volume is not uniform. Other difference between we have difference between numerical and experimental results also in the zone far from the crack tip. In fact, numerical experimental results show compression state in this zone. Also, the experimental results have no regular trend. Okay. This problem is due compression states, and the strain oscillation is due to the first problem is due because in the zone of in this zone it's possible to find a residual stress due to the cut of the notch, while the no regular trend is due to the neutron measurement. The neutron measurement is carried out on the wide gauge volume. Okay. Also, the microscopic structure of material influence the measurement. In fact, in the zone far from the notch, we have a highly preferred orientation of the grain of the structure. Okay, and this influence the measurement. Moreover, this microstructure is different of other zone of material and also is point dependent. Okay, Anyway, in the same way, we have studied short crack spaceman. Also, in this case, the crack is not in the middle section of the spaceman. The spaceman is also modeled with 20 nodes, elements with 3 degrees of freedom for each node. Also, in this case, we have created 3 models, full-scale 3 models, and 3 sub-models. In this case, the convergence parameters is von Mises stress, and the convergence model is model 5. These figures show the strain, longitudinal strain in different 3 planes for zeta 1, 2, and 3 millimeters. This is a transverse strain. Also for synchrotron radiation diffraction measurement, we have 2 different measurement numerical evaluation value, local and average measurement. And in this case, the gauge volume is the size of the gauge volume is 0.5 millimeters. Also, in this case, we have a difference. We have compression state in zone far from crack tips for longitudinal state. Also for transverse strain, and also in this case the difference, some difference. The reason of this difference is the presence of the higher preferred orientation in the material grain. In fact, this figure shows the influence of the microstructure. In fact, this figure shows the experimental measurement for unloaded and loaded specimen. For unloaded specimen, the peak 111 should be more intense of the peak of 200, but it is not. And when applied in the loaded, the peak 311 disappears. So the microstructure, this figure shows the influence of microstructure. In conclusion, we have created the mesh model is convergence. The results are consistent and coherent with phenomena. Average strain value is more consistent of the local one. Numerical results no show the compression state. Almost good numerical correlation is the for longitudinal state near the crack tips. Difference between numerical experiment is higher for the definition of transversal strain. This difference is due to the residual strain stress in the stress. The gauge of volume affect the measurement. Also, we have a good correlation from numerical and experimental results.